Hello, this talk is about the current state and future of the Jakarta EE platform. My name is Reza Rahman. I'm giving this presentation on behalf of the Jakarta EE Ambassadors. I'm also an author, blogger, and speaker. On screen, you see my email address and Twitter handle. Feel free to reach out to me if you have any questions on this topic. So aside from giving you the presentation and talking about the current and future of the Jakarta EE platform, there is another purpose for this video that I would like to explain. So a generic version of this presentation is available as part of the Jakarta EE Ambassadors resources. The purpose for that resource is so that you yourself can adopt and adapt that material and present it yourself. So in this particular presentation, other than giving you the information, I also hope to give you a rendition of how this presentation could be delivered, and you can obviously take any part of this presentation and modify it in any way that you like. The basic objective is to give you an example. Okay, so what is Jakarta EE specifically? Jakarta EE, in case you don't know, is the technology that used to be called Java EE, transitioned from the JCP to the Eclipse Foundation. And as part of that transfer, there's some rebranding that needed to take place, and we'll talk a little bit more about this in a second. But basically, the technology is now called Jakarta EE. The big difference between the JCP and the current formulation is that it is far more open. So it is under completely open governance. It is completely open source, even including the compatibility testing kit. So under the JCP, it used to be that the TCK was not open source, but now it is. So if you want to certify against any of the Java EE TCKs, you can now do so. And you can even contribute to the TCK if you like. Similarly, pretty much everything is a lot more open than it used to be. So really, nobody has any special privileges under the Jakarta EE regime. So we do have a well-defined specification process, just like we used to have under the JCP. In fact, you could argue that it's a bit more transparent. There is very clear IP flow. The IP flow used to be very centered on Oracle and Sun. Now that is really not the case. It is more or less a shared pool of IP flow that is far more open again. It is very, very vendor neutral. So there is a specific focus on vendor neutrality in Jakarta EE and having a level playing field. Not just with all the vendors, but you also included. So you as a community member actually now have far more opportunities and ways of contributing to the technology and having a say in the technology. In fact, if there's one key takeaway that I would like you to consider as part of this talk, is that now is the best time for you to get engaged in moving the technology forward, in determining its shape, and also helping contributing to it in a very direct way. Now, of course, Jakarta EE is a very large technology set and a very important technology set. And one of the important parts is strong vendor support and strong corporate support. And that continues to be the case, including Oracle itself. In fact, Oracle remains one of the key contributors to Jakarta EE. But there are other players as well, many other players, including IBM, Payara, Pivotal, and of course you, the community at large. In fact, the community at large has been contributing quite heavily. The second largest contribution does come from the community, so folks like yourself. So if you want to find out more about Jakarta EE, the best place to do so is to log on to the Jakarta EE website. I won't talk too much about it. There's many nuances that you could talk about and really understand why this technology is far more open and why that is so important. This is basically the first time such a large part of the Java EE, or rather Java platform, has become open source and has become really so open in terms of its ability for many people to participate. And in fact, it's very unique. You might say this is probably the most significant and most open part of the Java platform and Java ecosystem overall today. So definitely an important thing for you to consider. So I think we all know the evolution of Java EE as a technology. It used to start with something called JPE. For those who don't know what that stands for, is Java Professional Edition. And then the technology became J2EE and really undergone significant investment from Sun at the time, and led to the popularization of the technology and in fact the relevance of server-side Java in general. From there you had the evolution from J2EE to Java EE, focusing much more on simplicity as well as essentially covering more use cases in a more easy way and keeping the platform up to date with the needs of the ecosystem. And that went all the way to Java EE 8. From Java EE 8, you had the transition to Jakarta EE. So the first release under Jakarta EE was Jakarta EE 8. Jakarta EE 8 is basically binary compatible technology-wise with Java EE 8. There's no technological differences. The big difference really is that Jakarta EE 8 is released under completely open source governance at the Eclipse Foundation, including the open source TCK. Now, beyond that, what you will soon have is Jakarta EE 9. As I mentioned, there is a bit of namespace and branding transition that we needed to do. So aside from renaming the technology, we also have to move away from the JAX namespace moving forward. So any further changes will have to take place under the Jakarta namespace rather than the Java namespace because of disambiguity in naming these two technologies. So that is in fact what Jakarta EE 9 is mostly about. I'll talk a little bit more about Jakarta EE 9 in a second, but basically it's about renaming the package names from JAX to Jakarta. And then finally, in Jakarta EE 10, which is not yet to be determined what that is, and we'll talk about that in a second as well, that is really where the innovation will begin to happen. So we'll begin to reap all of the benefits of all this openness and being able to move the technology into a place where it can be participated in by many more people in an open fashion, implemented in a more open fashion by many more people, and hopefully also accelerate faster than certainly what Java EE used to be. So those are the principal objectives of moving the technology to the Eclipse Foundation to begin with. So let's take a look at Jakarta EE at a glance. And as I mentioned again, it's not very different from what Java EE 8 is. But what I've noticed is not a lot of people know what is in Java EE 8. So at least a part of this presentation will be spent taking a look at what precisely is in Jakarta EE 8. Now, one of the interesting things that actually happened in the Jakarta EE transition is that in the JCP world, we used to use a lot of acronyms. CDI, JPA, and so on and so forth, JAX-RS and so on. So in Jakarta EE, we've essentially gotten rid of all of those acronyms and began naming things in a much more simpler way. So instead of JSF, it's Jakarta Faces. In case of JPA, it's no longer JPA, it's Jakarta Persistence. It's Jakarta RESTful Services, Jakarta Bean Validation. So these are much more simpler to understand and to comprehend names as opposed to the acronyms that we had under the JCP. And in fact, throughout this presentation, I'll be using this new style of naming, simplified style of naming. So in Jakarta 8, there are several themes that I've outlined in this in this slide deck here. So one is the web standards alignment. So luckily for us, the web standards are certainly moving much faster than they used to, certainly since the 90s. So there's a lot more innovation going on in places like the W3C. And one of the key objectives of Jakarta EE 8 is to stay relevant and to adopt all of these changes. So some examples of this is Servlet 4 or HTTP2, adoption of server sent events, the JSON binding support, JSON pointer support, adopting things like JSON patch, and we'll talk about a lot of these things in detail, of course, in a moment. There's also some alignment with CDI. So as of Java EE 6, really CDI is a key central component model. In J2E, it used to be EJB. That's not the case with Java EE 6 onward. So more and more in every single release, we align more and more of the platform towards CDI. So in Jakarta EE 8, a few important things happened. So we saw the major release of CDI 2. This is the first major release of CDI for a while. We used to have basically point releases, CDI 1.1 and 1.2. You have pruning of one of the redundant bean models, which is the JSF managed bean model. So faces bean management beans are essentially pruned at this point. You can also have greater injection capabilities with technologies like faces and persistence. And we'll talk about more of that in a second as well. And you'll see more and more of this, more and more technologies being able to take better advantage of CDI as a platform. There's actually quite a bit of that already, but there's few places here and there where this could be improved as well. Now, simplicity has been a theme, obviously, as I mentioned, since Java EE 5. So the two things that were simplified in Jakarta EE 8 is security, which we'll talk about at a later stage, and also pruning some of the older Java EE, or rather EJB technologies. So this also you can consider it perhaps part of CDI alignment as well. Lastly, the Java EE or Jakarta EE platform has always taken advantage of fundamental innovations in the ecosystem certainly, but more specifically in Java SE. So in Java SE 8 in particular, as you know, there was a number of very important changes that are very useful for enterprise Java developers. So these are things like repeatable annotations, the datetime API, streams, completable features. And in fact, what has happened with Jakarta EE 8 is a lot of these features, in fact, were assimilated into relevant standards like Jakarta Faces, Jakarta Persistence, Jakarta RESTful, web services, and bean validation. And we'll talk about each of these in turn later on in the presentation. So let's start with Jakarta Servlet 4. This is perhaps one of the most important features that has come about in Jakarta EE 8. So what is it precisely? So the principal objective of Servlet 4 is really to bring HTTP2 support into the platform and into the Java ecosystem. In case you're not aware, HTTP2 is a very, very significant change to the fundamental protocol basically powering the entire web. So in order to understand this, you will need to turn the dial back and do some time traveling back to when HTTP was first conceived. So when HTTP was first conceived, a lot of the web pages looked a lot like Wikipedia. So basically you would load a page and the page would mostly be self-contained with a lot of text in it and not many other resources, maybe a few images here and there, but that's a rarity. It's mostly about text. And then there would be hyperlinks, and once you click on that hyperlink, you would go to another resource, that would load up, and it would be another HTTP request altogether. So this simplicity was a reflection of the world back then, and also because it was the initial release of this standard, it was deliberately kept simple so that everybody could implement it very easily. Now, time travel back to the present time, the web has evolved as it should. It has built upon its success and it has evolved. Now, if you look at the typical website or web page today, it is no longer very textual. Regardless, there's definitely a lot of text, but in addition to the text, there's a lot of other things to render that page, like images, CSS, JavaScript, videos, and so on. Right. So on average, if you look around, you'll see that it's about 40 resources that a particular web page needs in order to render itself. So what this means is, using the old HTTP protocol, you had to make 41 different requests, distinct requests, to get that page rendered in a very linear fashion. So this obviously has performance implications, and this is the problem that basically HTTP2 solves, but it solves it in a clever way without changing actually the API for HTTP. So the API still remains the same. What changes is the plumbing of and how things are done. So instead of just opening and closing so many connections, HTTP2 treats these connections as a scarce resource. So basically what happens is, the browser and the server make a single connection, as you can see depicted in the image that I have. It's a single connection under which all of these resources are being interchanged. Right. So the way this is done is to break a single connection up into streams and exchanging data back and forth from the client and the server using these streams under the same connection. This is really what's called multiplexing, and it's a very old technique actually. So in addition to multiple streams, each of these streams have prioritization. So this helps the browser determine which of these resources should be handled in a more important fashion than the rest. In addition to that, HTTP2 comes with another important technique called server push. So using this technique, basically, if the server knows that given a resource, you'll need many other resources, instead of the browser ad hoc requesting each of these resources, the server simply gives those resources to the client in a proactive way, further reducing the need for making explicit requests for things that you would need anyway. as it so happens, the HTTP2 protocol, instead of being text-based, is also binary-based. So this also, as you can imagine, improves performance quite significantly. And HTTP2 also comes with one last optimization technique called header compression. And what this is all about is basically when you have these closely interrelated resources, the headers for them tend to be the same. So instead of exchanging headers for every single resource, what the client and the server can do is basically agree to only exchange the headers that actually change. So typically this would be like the name and the size and the type of a particular resource, and not change the rest of the headers, in net exchanging less information. So as I said, and all of these changes can take place without changing the HTTP API. And what that means for Servlet 4 and Java developers is a lot of these changes, and a majority of these changes, can be done without actually you needing to change anything at all. So all that Servlet 4 really does is ensure that a Servlet 4 implementation correctly implements HTTP2 under the hood. And basically what this enables you is to upgrade your Servlet engine and take advantage of all of these nice performance improvements. The only exception to this is really the server push API, and that is also opt-in, so it's backward compatible. You won't break just by upgrading. You can take advantage of server push yourself, and in fact, if you're using something like JSF is already designed to take advantage under the hood of handling server push without you knowing about it. So if you're using JSF and you upgrade, you'll automatically be taking full advantage of HTTP2 without actually having to make any code changes whatsoever. So let's move on to JSON binding. So as you know, in the Java and Java EE platform, things that are sort of you can count as built-in serialization mechanisms is Java serialization and XML. And it is so much a part of the platform that you often don't really think about it. You think about it as intrinsic parts of the platform. So, but as we know, part of the web standards acceleration has been JSON. So JSON actually tends to be used as a de facto serialization platform far more often than it used to be in the past. And this is not just about JavaScript, but really all kinds of client and data interchanges are really happening using JSON. So JSON, similar to Java serialization and XML in the past, needs to sensibly also become a default part of the platform. So that is basically what the Jakarta JSON binding API, or simply the JSON binding API, does for short. It allows you to very simply and almost by default be able to translate back and forth a POJO between JSON and back. So there is a small number of annotations that will allow you to do some customizations on top of that, like JSON property and JSON transient. So these two annotations, for example, will allow you to rename a field in a POJO, and JSON transient, as the name implies, basically says, hey, don't use this field for serialization and deserialization purposes by default. So another nice thing about all of this is that JSON binding is built into and tightly integrated with the platform, including Jakarta REST. So what this means is now you have a built-in way of handling anything that is of type application JSON in a REST endpoint. So one thing to note is that this did used to exist pretty much as of the Java EE6 timeframe for vendors, but it was provided in a vendor-specific way. For example, a vendor would provide built-in integration with JAX-RS. Obviously, that's a non-standard API, whereas JSON binding is a standard API. So that's the big difference between prior to Jakarta EE8 and after. So here's a simple example. Over here, I simply have a REST endpoint, simple REST endpoint that implements GET. So in here, what I can do is I can retrieve or construct a POJO, just like I'm doing here, and return this POJO as part of my REST payload. And all I need to make sure is that it is producing the application JSON type, and as a result, what will happen is I'll get a sensible JSON representation without really having to do anything, integrating third-party libraries, configuring them, so on and so forth. None of that exists. It just works, just like it does for a vast majority of things in the Jakarta EE platform. So in addition to JSON binding, there's yet another API that has been available in the platform since Java EE 7, and that is called JSON processing. So unlike JSON binding, which is a higher level API that uses annotations and POJOs, basically what JSON processing does is it's similar to the older style XML processing APIs. It allows you to programmatically process JSON as opposed to doing it in a declarative fashion. And why would you do that? Normally you would do that to when you're using ad hoc JSON processing that cannot be determined ahead of time. And also if you're doing minor cases where binding is overkill. So there's many different use cases for this lower level API. And it's relatively feature complete, has been in Java EE 7, but there was a few things that were added, primarily responding to, again, innovation in the web standard space. So two different web standards that were integrated into Jakarta EE 8 or JSON processing 1.1, namely JSON pointer and JSON patch. There was also some other things done as well. For example, there's alignment with yet another JSON web standard that's called JSON patch merge. And also Java streams alignment. And what this allows you to do is that it easily allows you to convert back and forth between Java SE streams and arrays of JSON in using this lower level API. So here's an example of JSON pointer. What JSON pointer allows you to do is to use a URL-like syntax in order to quickly navigate JSON elements, right? So you have two examples here. So I'm navigating to the first array element in phones, and then and navigating to the mobile element. So as you can see here, this work, if I was to do it without these facilities, would require a lot of tree traversal of the document to find out where exactly this element resides. Whereas in this way, it's much more compact and it's much more usable. So JSON patch is another important change that was brought into JSON processing. What is this? Well, this is a way of making bulk changes to JSON objects and basically expressing what changes you want to do in terms of JSON itself. As you'll notice in the examples, basically JSON patch uses JSON pointer as an underlying capability. So there's many different types of basically modifying or testing operations. So things like add, replace, remove, typical CRUD functionality, moving, copying, testing whether something exists, and so on. And so you see two examples here. So I'm replacing a value at in the mobile element that I was navigating to before, and I'm removing the first element from root. So those are the two changes that I'm expressing in terms of JSON patch. So this is how the API looks like. As you can see, those are the examples applied to a JSON document. And the API in JSON processing utilizes the builder pattern, so it's very, very compact. It allows you to do a lot of things very, very quickly as before, so you're not needing to do a bunch of document traversal. And also you can, because it's using the builder pattern, you can construct a set of JSON patches and apply them over and over again. So this is also a particularly strong capability that exists within this API. Server-sent events. So this is actually a part of HTML5. So it's been a little while actually since server-sent events were introduced. Initially, there was a consideration whether to include this capability in Java EE 7 or not, but ultimately we basically the decision was made to defer it until Jakarta EE 8. So what is server-sent events? Server-sent events is something between sort of the extremes of WebSocket, which is completely bidirectional, completely asynchronous modes of communication in HTML5. So this is useful in things like chat applications, for example, or massive online multiplayer gaming, right, where you need all these asynchronous messages going back and forth from the client and the server, and plain old vanilla HTTP, right? We talked about the HTTP. So you make one request and you get one response and so on. That world of just making a request from the client and getting a response from the server. So in this world, what you have is that you still get a connection between the client and the server initiated by the client, but instead of getting just one response, you get multiple responses over a period of time, or multiple events over a period of time. So a good example is something like stock tickers and monitoring applications. You want to monitor something, you connect up to the server and you say, hey server, I want you to give me a series of events over a period of time using the same connection that I'm going to reuse. So again, this capability actually existed in Jersey, which used to be the reference implementation for JAX-RS for a little while, ever since Java EE 7 actually. And mostly the API is what was the best practices that were learned from that API. Okay, so here's a simple example of it. So let's say I have my stock tickers example. So I have a JAX-RS or RESTful Jakarta REST endpoint. So I'm producing a type of endpoint that produces text/event stream, which signifies that this is actually SSE. So now I get to have a void return type. So that means that I'm not actually going to return a single response. I'm going to return a series of responses over a period of time. And two distinct APIs will help me with that. One is SSE event sync, okay, which you can think of as a basically long-lived connection between the client and the server, under which I send multiple responses or events. And then there's a utility object called SSE, and that allows me to do things like very easily create a new event from a POJA. So in this case, I'm taking the entire processing in a background thread using the managed executor facility available in Jakarta EE, and then over a period of time, as I receive stock updates, I'm going to send those stock updates down to the client. And of course, there is a client side rendition of this as well. I won't show that here. Jakarta Security. So this is, believe it or not, a new standard introduced in Jakarta EE 8. And then when I say this, a lot of people are immediately surprised. They say, okay, yeah, this is such an old platform, and why is this a new API called Jakarta Security? Well, for those of us who have dealt with the platform for a long time, what has happened with regards to security in the Jakarta EE platform is that Jakarta EE platform takes a very abstracted way of dealing with security. So security by and large is dealt with in vendor-specific ways prior to Jakarta EE 8. So you typically secure an application using some kind of vendor deployment descriptor, or more likely a vendor graphical user interface wizard to say, hey, I want to please take this application and secure it against LDAP or Open Directory and do the role mappings this way and so on. And basically the application would be content by simply saying, hey, I want to be secured. These are the roles that I recognize. Please secure these URLs and so on. Right? But the rest of it would be done outside the application. So this model has some strengths and will continue to have some strengths. But its big weaknesses is that it introduces a vendor neutrality or portability issue. So now if you go from one application to the other, you'll need to redo that work that was done in a vendor specific way. So that does not carry over from one implementation to the other. And it also is not that developer friendly, let's put it that way, right? So developers are not able to see, hey, what exact database am I securing against, and so on and so forth. So the objective of Jakarta EE Security is solving those problems, bringing more portability, allowing developers access to those type of security configurations, and also unifying the Java EE security concept a little bit as well. And we'll talk about how that's done through an example. That's the best way of showing it. So first and foremost, thanks to these changes, actually Jakarta EE Security is probably one of the simplest way of securing Java applications now. So let's say you want to secure against a database. All you really need to do is throw on this database, this annotation database identity store definition, and that's it. That's all you got to do. There's no vendor configuration, nothing much more else to do. Similarly for LDAP, right? So it's as simple as these specifying these annotations somewhere in your application. So let's say that you secure your application, but it's not against the database and it is not against LDAP. So what do you do then? So Jakarta Security provides yet another capability called simple identity stores. Right. So all you need to do is implement a CDI bean that implements this interface identity store. And basically, you'll be able to do security your own way using your own providers. So let's say I have some legacy service called user service, and then I can inject that user service within my custom identity store and do validation. So I'll get the credentials, probably use in username password form, do my thing, and then send over my credential validation result, or their success or failure. If it's success, then okay, this is the currently logged in principal name, here's their roles, and so on. Right? So you can completely customize your security if you so wish. Similarly, there is a security context that was introduced as a way of unifying doing security context handling. So security context handling in Java EE was done using different APIs in different places. So Servlet had one, EJB had one, and so on. So now instead of having all these discrete APIs, you have this security context that you can inject pretty much anywhere where CDI is available. And it will allow you to do things like do a lookup of, hey, who's currently logged in and what is their current role, as opposed to using different APIs in different places, or perhaps not even being able to use an API. Let's say you are in the data access DAO layer, where it's just just CDI. Well, now even there you can use a security context in this way. And of course, in my example, I'm using it in an interceptor. So you can apply this interceptor basically wherever CDI is enabled. Okay, speaking of CDI, the next change that I want to talk about is about CDI 2. So the big change in CDI 2 is that CDI is no longer just a Java EE or Jakarta EE technology. You can now use CDI anywhere where you have a JVM, because you now have a standard Java SE bootstrap mechanism. And this used to be proprietary. Weld used to have this API, and now all CDI implementations will have this API and be able to do bootstrap in Java SE environments or Tomcat environments, let's say. To go along with that, the CDI specification was modularized. So now there's a core version, and then a Java SE flavor and a Java EE flavor of CDI that's usable in different environments. You also have asynchronous events. I'll show you a concrete example of this in a moment. The other big change that was done is making the portable extensions API a lot more simpler. So this is to encourage even more ecosystem building around CDI. So if you want to create a CDI, if you have a product, you want to create a CDI plugin for it, it should be as easy as possible to do so using the portable extensions API. And similarly, there were some other Java SE alignment that was done in CDI as well. So things like repeatable annotations and the like. So here's an example of asynchronous events. So CDI includes a very type-safe and simple event bus that you can use. So this event bus used to be synchronous prior to Jakarta EE 8. In Jakarta EE 8, now you have the ability to have asynchronous events, meaning if you fire an event, this event can be observed basically out of the current thread, right, giving you a little bit more resiliency and a little bit more reactive style programming API. So instead of invoking fire, you now invoke fire async, and instead of observing an event using the @observes annotation, you observe the event asynchronously using the observes async annotation. Okay, relatively simple changes, I think. All right, so as we talked about, one of the major themes for Jakarta EE 8 is adopting Java SE innovations. Now, one thing to keep in mind is Java SE 8 and Java SE in general is designed to be basically forward compatible, right? So if you have a new version of Java SE and you have new innovations, the Java SE team by and large tries to see, okay, let's make this non-breaking and just work with the majority of the ecosystem. And so as a result, a lot of the Java SE 8 innovations and even Java SE 9 and forward innovations can actually just be used in Java EE applications as is, especially if you're using it where it does not intersect with the Java EE API and it's in your business logic. That's very easy to do. So this applies to things like streams, lambdas, and so on, and even the datetime API. Now, in some cases, you have to have built-in support for these APIs in Jakarta EE APIs themselves, and I'll talk a little bit about what each of these examples are. But basically, each of the Java EE APIs, wherever possible, has adopted to things like repeatable annotations, the datetime API, and completable futures and streams. Okay, so taking a quick look at this. First one is repeatable annotations. So prior to Java SE 8, you could not repeat annotations. So in order to get around that, you'll have this concept of wrapper annotations like named queries. Surely if you're using JPA, you're probably familiar with this annotation. So as of Jakarta EE 8, there's no need to do that. So because JPA has been retrofitted, in fact, more or less every place where there is a repeatable annotation in Jakarta EE, it has been retrofitted to be able to repeat annotations, just like the example below. So think about EJB or JPA. These are all bean validation. These annotations are all repeatable now. Similarly, the datetime API. So here's an example of where you have to have some kind of change in the Jakarta API to make things work. So let's say for a second that you have an entity, and in the entity you're choosing to model a bit of data, let's say in my case when an accident occurred, not using the old Java util time data objects, but using the new datetime API objects. So in Jakarta EE 8, the JPA will actually recognize this natively and be able to translate back and forth between the database and you transparently without you needing to do anything at all, like writing custom converters. Similarly, annotations like the bean validation annotations will also recognize how to handle the datetime APIs. So similar changes have been done in JSF as well, where you need to potentially render and convert these newer Java SE 8 datetime API objects. So completable futures are basically the promises of Java. If you haven't looked at it, I won't go into it in detail quite yet, but I urge you to take a look at what completable futures are. So completable futures are a hybrid between the old style futures that can be prone to premature blocking and callbacks. So it provides the benefits of both. So it is completely non-blocking. It is composable, just like you have in the example here, and it also allows you a relatively fluent API to do asynchronous reactive processing, especially in a complex interaction like this one. So one of the areas that I'm showing an example of here is where this comes in handy is the JAX-RS client API. So let's say you have you're developing a microservices based system, and your microservice talks to multiple other microservices to do a thing. And you want to do this in an asynchronous fashion for greater performance and reducing latency. So now you can use the completable futures in order to do this, because the Jakarta REST API has introduced this RX method. Okay, so that will allow you a return of a completion stage as opposed to doing things using callbacks and futures, which is also supported in Jakarta REST. So streams are also another thing that was adapted. Two specific examples of this. One is, as I mentioned, the JSON processing API. Another is Jakarta Persistence. Okay, so now you can actually create streams directly from JPA queries, and what this allows you to do is do a little bit more collection style processing of your query results. Now, do use this with caution. Don't think of it as a replacement to the where clause. The where clause probably by and large will still be more performant. What you want to do here is do any post-processing after a query is naturally done. Some other changes that I won't talk about in detail, and in fact this is not even a complete list. There's many other minor changes that were done in Jakarta EE 8. All in all, it's a very, very significant release, and honestly a very feature complete release. That has kept the platform relevant for a long time, especially thanks to something like MicroProfile, which we'll talk about in a second. But basically for monolithic applications, you have a very feature-complete platform. So you have things like WebSocket native integration with JSF or Jakarta Faces, greater CDI integration with Jakarta Faces, so being able to inject many more Faces artifacts like the Faces context, for example. More important bean validation constraints were added. In my example, I was showing an example of just one client-server based communication. You can actually broadcast SOC events not to just one client but multiple clients. That capability is also built in. You can order events in addition to being able to invoke them asynchronously now. And as I talked about, there's also Jakarta Stream support in Persistence. Okay, so let's move on. We'll talk about Jakarta EE8 implementations. So actually there's a number of these already. The big one that is missing on this list is probably WebLogic, and that's coming soon as well. So you already have a lot of places where you can begin to use Jakarta EE8 and begin to adopt and move to this platform. The full list of compatibility you can find on this website. So what is in Jakarta EE9? So Jakarta EE9 is going to be done pretty soon, probably in just a few months. The big change here is to move from the JAVAX to the Jakarta namespace. As I said, we needed to move away from this namespace because we're moving the technology away from the JCP. There was some removal of the older technologies that were slated to be removed, and there's really no sense in moving these forward. So example of this is JAX RPC, for example. There is also very likely going to be some additions. So this is because Java SE deprecated some of these technologies, so they need to be re-added into the platform. And it's primarily adopted not to end users necessarily, but to the ecosystem, the vendor ecosystem and the implementation ecosystem, so that they have a chance to absorb this renaming change. So there are some mechanisms like Eclipse Transformer that can make this transition easier as well. So this does not necessarily need to be a very difficult transition. So the milestone release for Jakarta EE9 is out, which means you can begin testing Jakarta EE9 transition yourself. But your contribution is also very welcome. So this is the very first time where end users can and are very, very heavily involved in the Jakarta EE9 milestone, and you can still do that. So the way you do that is you get involved, and we in the Jakarta EE Ambassadors actually have a guide to help you with this. A lot of people have used this guide already. You can also use it by following this URL. So the discussion would not be complete without talking about MicroProfile. So MicroProfile happened at about the same time where Jakarta EE8 was being formulated and the technology was being moved from the JCP to the Eclipse Foundation. Obviously, this transition was going to take some time, so the platform needed to move forward. So a way of keeping the platform and ecosystem responsive, especially to changes like microservices, is this effort called MicroProfile, and this is basically a set of open standard specifications, also part of the Eclipse Foundation. So you can take a look at this technology yourself by logging onto microprofile.io, but it solves use cases very specific to microservices often. Right? So these are things like open tracing or distributed tracing, open API or Swagger documentation, having type-safe REST clients where you don't mind a little bit more tight coupling between a REST client and a REST server, centralized configuration outside of your microservices, doing things like fault tolerance to increase the resiliency of your microservices, metrics to do centralized monitoring of your microservices, JWT propagation in order to do single sign-on across microservices, health checks to check for the health and resiliency of each of your microservices, and so on. So MicroProfile. So now that there is Jakarta EE, and now that Java EE has moved to the Eclipse Foundation, it's an open question: what happens with MicroProfile as a technology? Does it stay on its own? Does it get merged with Java EE? Does it get merged with Jakarta EE? What happens with it? Because it's two similar things that more or less serve the same audience. So I've been trying to figure out the answer to these questions, and the way I did that is I talked to all of my friends, and I also try to make use of the resources that I have. And one resource that I have is my Twitter following. Follow people that follow me on Twitter and trust in what I have to say. And I tried to ask them, hey, what do you want? And by and large, it seems that the desire is to not have two different technologies, but only one technology, as you can see in the results of this poll, and also of this poll, right? So there's also not just a desire to merge these technologies together, but also make them look the same, make them look consistent under a single umbrella. So if you have opinions on this, this is a pretty hot topic that is not yet to be completely determined, and you should provide your input. Just like I have, just like many other people have, you should not be shy in providing your input of what you would like to see between these two technologies, Jakarta EE and MicroProfile. Okay, so now let's talk a little bit about Jakarta EE 10 possibilities. So we actually have a reasonably good view of this in the Jakarta EE Ambassadors, because we feel that there's a lot of long-standing things that could be addressed by the technology that has sort of not been addressed because of all this transition work. So here's some example of this, and we actually hope to publish a guide on this as well. And part of the guide is going to be, your contribution into these things, and what are these things that we see, at least on our side. So here are some of the big ticket things. So Jakarta NoSQL is a standard for allowing NoSQL access to Jakarta EE applications. So this used to be called Eclipse JNoSQL. Now it's called Jakarta NoSQL. It's pulled within the Jakarta umbrella. So quite possibly this could be possibly an optional part of Jakarta EE 10. Jakarta MVC. This is another technology that was evolved in the Java EE 8 timeframe. Used to be in the JCP called Java EE MVC, and now that's pulled into the Jakarta platform called Jakarta MVC. So again, it could make sense to have this as a part of the optional part of the Jakarta EE 10 platform. We could move forward in deprecating EJB altogether and moving all of the functionality into relevant specifications like messaging, concurrency, security, so providing CDI based equivalents of all these EJB features. Further strengthening Jakarta Security by introducing more modern authentication and authorization mechanisms like OAuth 2, OpenID Connect, JWT. These very clearly are common needs. Doing more Java SE alignment, so there's a little bit left to be done, specifically in Jakarta concurrency, adopting things like CompletableFutures, and maybe introducing Java records in alignment in Jakarta Persistence. So those are some of the areas where more Java SE alignment could take place. Potentially adopting the Java platform module system into Jakarta EE. That's yet another Java SE alignment feature that you can think of. More CDI alignment, so there's some bits and pieces of the platform that could use more of this. So batch is a good example that could use more usage of CDI. Jakarta REST is another example. And one of the key things that is in MicroProfile today that is a very common need, and that is externalized configuration outside of your application. Simple things like environment variables and so on. A lot of those capabilities you can argue that actually belong and is a very common thing that can be utilized even by Jakarta EE APIs themselves, like Jakarta Persistence and Jakarta Messaging. So one possible answer here is to include that capability in the Jakarta EE 10 umbrella somehow. Okay. So I talked about the Jakarta EE Ambassadors. I'll talk about it a little bit more here. So we are basically a grassroots entity. We are not completely vendor neutral, not associated with the Eclipse Foundation. The Eclipse Foundation is gracious enough to allow us their branding and to recognize us as a group. But other than that, we are independent of the Eclipse Foundation also. Our job is basically to promote and move forward Jakarta EE in the community in whichever way that we can, by evangelizing it, just like I'm doing at the moment, and hopefully you'll consider doing, keeping track of things, helping contribute and encouraging people to contribute, helping shape the direction to make sure things are aligned with user needs. Those are all of the things that we do in the Jakarta EE Ambassadors. Anyone can be one. There's no special capability that is necessary here. You can find out more about by logging on to jakartaeambassadors.io or following us on Twitter. Okay, so Jakarta E8 is very, very significant. It's significant to the future of Java. Jakarta E9 is coming soon, followed by Jakarta E10 and beyond. The time for you to get involved is now. Don't delay. Begin using this technology. Begin trying out. Begin adopting Jakarta 8. Begin trying out Jakarta E9, and begin engaging in both Jakarta E9 and Jakarta E10. All right. So here are some resources that I'll finish up with. Obviously, we talked about the prior resources like the Getting Started Guide, the Jakarta EE official website, the Jakarta EE Ambassadors website. But other than that, there are some other resources that you can follow to learn more about the technology. So one very good place is Jakarta 1, especially Jakarta 1. The first edition will give you a lot of overview in all of these technologies in much greater detail. It's close to 24 hours of content, so feel free to take a look at there. The best place to get involved initially, aside from the Jakarta EE Ambassadors, is a Jakarta EE community alias. So if there's one Eclipse Foundation alias that you follow as somebody interested in the technology, this is the one. You can also follow the Jakarta EE official Twitter handle. There's good information that comes out of there. And there's also a program called Jakarta Tech Talks. It's a virtual group where every month or every other month in a regular cadence, there are talks delivered on Jakarta EE topics. So you can get involved there and learn more about Jakarta technologies and stay up to date that way as well. Thank you very much. That's all I have for today. Hopefully this was a useful presentation, and I really do hope that you adopt this presentation and present it yourself, perhaps in your work or perhaps in your Java user group.